Sitting here just waiting, watching. Check this out. Little lizard just came up to say what up. Little dude right here. It's pretty cool.
This video is brought to you by SPORLAN. Quality, integrity, and tradition.
Alright, well, it's about 9:20 at night. I'm heading out to a walk-in freezer service call. This is a really frustrating one because I have been there 2 times in the last week and a half to defrost this walk-in freezer, and there's nothing wrong with it. The customer, their reach-in freezer's broken and they're replacing it, and they've got a new one coming. So in the meantime, the cooks are all using the walk-in freezer as a reach-in cooler, so they're in and out of it every 5 minutes, and they're propping the door open and they're constantly making it freeze up. It's frustrating, you know. I kind of feel bad because I had a conversation with the manager on the phone, like, dude, this is getting ridiculous. I can't keep coming out to do this, you know. And I feel bad because, you know, I was kind of making him, you know my frustration. But it is what it is, so let's go see what we can get into. Alright, so it's partially iced up, and it sounds like one of the motors is going bad or something. That's weird. Alright, well, we're going to get it shut off and defrosted. Alright, so you can see ice build up like crazy on this guy. So first thing we do is turn off power outside. That way it's safe. And then we're going to try to defrost it. Now the fan brackets and everything, I like to take fan motors out usually, but they're frozen in there. So we got to carefully defrost around them without getting the motors wet. And then we'll pull them out and make sure we get all the way through the coil. These coils are really jacked up too. They're like all bent, the fins down in here, all back here. And then the backside's messed up too from them smashing the heck out of it. I really, you know, this equipment needs to be replaced because it's just in horrible shape, but I just don't have the time. Like, or the patience right now. I'm just so swamped. I'm like a week or 2, no joke, behind on service calls. Like, because we keep getting walk-in freezers and air conditioners and ice machines, I keep pushing off like reach-in coolers, and I have just a backlog of them. I guess it's a good problem to have, but... Alright, well, this guy's just about defrosted. I need to do an inspection to make sure it's completely all gone, but I think it is. All back in there. I just recently had redone the drain. It used to run down over to that corner right there, but homeless people live on the other side because this is an exterior walk-in, and they keep jacking the drain lines and messing it up. So I re-ran it just outside the back here where it's behind a gate that they can't get to. It's funny, like, this is behind a gate, that is not, but that's just how it is. So we put a new drain line heater on it too, so that's working good. Coil is just all smashed up. I mean, it's not the worst shape, but it's not in good shape by any means. So, okay, we're defrosted. A little bit on here. I'd like to get it off the suction line too, but I don't want to break anything. I don't have any insulation on me right now. Yeah, this is jacked. All jacked up. Damn it, these guys keep icing this thing up, pissing me off. Alright, well, we're just about done, and we'll get up top and just gonna still double check everything. Alright, it's all back together. Leave the side panels off right there. We're going to turn on power and then test everything out. Make sure everything's good. Nothing wrong with the fan motor, so it was just hitting ice or something funky like that. So we're going to go put our gauges up on the roof, make sure everything's good up there. Alright, we're going to open up the high side. We're running a clear sight glass, so that's good. All looks well there. Alright, so this one right here, a lot of people get confused by these. This guy works backwards from a normal valve. So this is the process port. This is our port that we put a pressure control on. So you're actually going to back it out to let pressure into this. And I know that's a little confusing for most guys, but got to remember that. I can't tell you how many times I found these things backed all the way out with a cap on the end. And people just don't understand it. Alright, so I've got an air probe in there. It's 29 degrees in the box right now. See Still coming down. 80 degrees outside. I'm not seeing anything too scary with these pressures at the moment. The box is still stabilizing and coming down to temp. We're gonna let it run for a few more minutes, then we're gonna throw it into a defrost at the defrost clock right here. And come to think of it, we might add some more defrost to this guy, because 4 defrost right now probably isn't enough for what they're doing here. Because again, one of their freezers is not working, like their reach-in freezer, so they're using the walk-in freezer like in and out constantly, causing it to freeze up. So we might have to add some more defrost to kind of compensate for that. I went ahead and initiated a defrost, so it's pumping down. That condenser fan motor is off of a pressure control, so it's still going to run until the pressure gets low enough. So we need to go downstairs and make sure that all the heaters are working on the evaporators. When it comes to these guys, you got a couple heaters in here, okay? That's one heater. It has 2 sides to it, right? So that's one heater. There's another heater down below, and then there's a drain pan heater. So we got to test on those guys. So one of them's at 2 amps. That one's at 2.15. That one, and that's it. So all the heaters are working. This thing is doing everything it can. So I'm not seeing any reason for it to ice up. The defrost clock had the right time on it when I got here, so it's moving. I mean, other than this thing just being a jalopy, it's doing everything it can. All right, everything is looking good. I'm not gonna do it tonight, but I think I might come back and put in a Graslin defrost clock. That way we could be more aggressive with the defrost strategy. Yeah, I'm thinking about it, but tonight is not the night. It's 11:04, so I don't want to spend another 2 hours here trying to wire in a defrost clock. I just want to go home and go to bed. I got to change a compressor in the morning on a set of coach drawers, so yeah, we're gonna wrap this one up. I mean, I don't know what else to tell them except for to keep the damn door shut, you know? All right, we are back. Got it defrosted. The last clip you saw that night. We came back out today to try to dig into it, and it's actually frozen up again. So we got to dig a little bit further now that it's not the middle of the night and figure out what the heck is going on here. It's solid top to bottom, so why is it doing that? This thing is frustrating as all get up. Thermostat doesn't look to be set too cold, but we also got to make sure that's shutting off. We'll have to figure this out. First thing I did was come up to the roof, and this clock did not have the right time on it. Every time I've been here I think 2 times, and the clock had the right time, but today it didn't. So I just turned it into a defrost, but it said 3 p.m. and it's only 10:20 a.m. So it looks like maybe the clock might be our problem. When I was coming back out here, I decided I was going to change this clock anyways, even if I didn't see the incorrect time on it, just because this is like the second time we've had to defrost it and I can't find anything wrong. So the clock has been keeping time every single time, but I think that every once in a while it's getting stuck at a defrost or something. It's hard to say. So I went ahead and went in with a Graslin. Now I interchanged between both of those. This time I used a Graslin because I want to be able to put more defrost in the middle of the night, and I want to do 45-minute defrost in the middle of the night and then half hours throughout the day. So we're going to put the cover back on, and then I have another tech downstairs defrosting it. Once we get it defrosted, we're going to do a full analysis on this system, check the TXV, make sure it's working right, check everything we can. So we're going to get down and dirty here in a few minutes. All right, we're getting the probe set up. Got a giant rat, dead rat back there, down on the bottom, big old furry thing. It's nice. We got the defrost clock installed. I'm just waiting for my tech to give me the go-ahead so we can turn it on. He's just assembling the evaporator right now, so. All right, so my system is running, but the evaporator fan motors are not on yet. You gotta give it time to get the coil cold enough for the evaporator fan motors to come on. My sight glass is even flashing, so you can't just assume. That's normal when the fans aren't running. See, we're running a really low evaporator temperature, but in a few minutes, you'll see that suction pressure, evaporator temperature rise once the fans start running. And there we go. So evaporator pressure is rising, suction line temperature is rising. So now we gotta wait for the box to get cold and stabilize out. Let's see what our box temperature is. Box temperature is about 30 degrees, so it's going to take some time. Bring the temp down, and then we'll test the evaporator superheat to see what it's at, and just monitor the system. So we're going to let it run for a bit. I went ahead, we had a water hose nearby, and this thing was kind of dirty, so I went ahead and cleaned the condenser. So that kind of put a wrench in everything, because it dropped my, you know, condensing temp, dropped my suction pressure. We'll give it a few minutes to warm up. It'll evaporate that water, and then my system pressures will start to stabilize out. One of the fan motors cycled because, you know, it's off a fan cycling control. So all right, we're gonna let this keep running. Sitting here just waiting, watching. Check this out. Little lizard just came up to say what up. Little dude right here. It's pretty cool. Little guy. Random that he's up on top of this walk-in freezer, but he's just chilling. So yeah, we're just waiting, watching. It's looking good. I mean, superheat's still high, but the box temp is still high, so you don't want to adjust on the expansion valve till you're getting closer to temperature. It's about 16 degrees in the box, where our set point is -10. So I personally wouldn't adjust on the expansion valve until you got to about 0 degrees-ish, and then maybe start adjusting, but just be cautious. I'll go check the frost pattern in a few minutes. So far, we're looking pretty good. All right, we had our return air probe in the wrong place earlier, but I moved it to the return air. It's about 20 degrees in the box right now, and we've got about 14 degrees superheat. The valve looks fine. The coil's not frosting up in any weird ways or anything, so I'm pretty happy with that, the performance of the expansion valve. The pressures don't scare me. Everything looks okay. Sorry about that weird line right there. The sun's acting weird. Yeah, looking pretty good. I wanted to watch this thing come down to temp, but I'm getting so many service calls I can't.
All right, at this point, in speaking with the customer, we looked at the shape of the equipment, the age of it, and we decided it would be in their best interest to go ahead and replace the equipment. Now, with this particular customer, they're very proactive about replacing older equipment because they really don't like the downtime. This equipment was certainly eligible for that criteria that they have as far as why they want to replace and when they want to replace. So we went ahead and we're going to do a load calculation on the equipment right now. I'm going to walk you guys through the process and the steps of doing the load calculation and how I determined what equipment is going to be right for their particular situation, okay? But with that in mind, some really important things we need to understand is there's a new federal mandate by the Department of Energy. All new walk-in installations, whether it be coolers or freezers, if they have a square footage of 3,000 square feet or less, they have to comply with new energy requirements for the walk-in coolers and freezers. Think of it as like, you know, the SEER ratings that we have for air conditioning systems. The air conditioning system has to be so efficient, right? That kind of stuff. In my opinion, this is going to get a lot more stringent, but right now we're in its infancy and it's just being introduced, okay? So, the things that they want to see with the new equipment is they want to see energy efficiency. They want to see less electrical consumption, more bang for your buck, okay? A lot of the manufacturers have different methods of achieving this energy efficiency, but one of the more common methods is to bring the condensing temperature, the operating condensing temperatures of the equipment down, okay? So how do we do that? Well, in the winter time, we will artificially increase our condensing temperature by flooding the condenser with liquid refrigerant, reducing the condensing surface space, so that way it drives the head pressure up, okay? We call it a flooded system, head pressure control valve. You can also do that with fan cycling. In the summertime, all right, what we're going to do is they actually are going to oversize the condensing units. The condenser surface area is going to be bigger. Therefore, it's going to drop the head pressure. Now, these are just some of the ways. There's other methods that they do it too. In the evaporator, they're going to put ECM motors on everything now. And they're also going to go one step past an ECM motor, and they're going to do 2-speed evaporator fan motors. So when the system is calling for cooling, the fan motors will ramp up to 100%. When the system is not calling for cooling and it's just circulating air, sometimes they'll either turn off the fans or they'll slow the fans down. That's the most common way. They slow the fans down to low speed, okay? Now, there's good and bad things about all these things that they do. On walk-in coolers, slowing the fans down on low speed is actually problematic, especially with restaurants that are in and out of their equipment a lot, because when the system goes into defrost, technically it's not calling anymore, so the fans slow down to low speed and it's not moving the air across the evaporator fast enough, and you can run into freeze up problems. But that's a whole nother issue. Okay, this is a walk-in freezer. So I'm going to go through the process of showing you guys the load calculation, and then we'll talk a little bit more about it as the video goes on, okay? All right, now this is the Rapid Spec program. This is Russell Refrigeration's load calculation program. You don't have to use this one. You can use any load calculation program as long as you get the criteria put in there. You can also do a hand load calculation if you want. You can download the Heatcraft engineering manual. You can look it up that way. There's a couple different methods, but I like electronic. It's easy just as long as you input the right information. But understand something. A load calculation program is only as good as the information you're feeding into it. I can easily manipulate this program to do all kinds of stuff, okay? So you want to be straightforward and answer the questions honestly, and it's going to walk you through this, okay? Now, this is my total information. I like this information because I like Russell equipment. This gives you an equipment matchup and make sure that everything's good to go. But you could use this program and then just see what the evaporator and condensing unit BTU requirements are and match up any other equipment if you'd like to too. And understand these prices are not accurate. This is net price before discounts and all that stuff, okay? So what we're going to do is we're going to click on this guy right here, and you're going to see the criteria that I put into the system. We take an indoor measurement of the indoor space of the walk-in freezer. So it's 10 feet deep, 8 feet wide, 8 feet tall, okay? Then what you're going to do is you're going to go in here, you're going to set your room temperature. I want to maintain negative 10 degrees Fahrenheit inside the box. You can configure your wall temperatures, okay, looking at the different walls. So if you look at this, I have one wall, which is where the door is at. I have the surface temperature of that wall at 75 degrees because that's inside the building. Every other wall is on the exterior of the building. I'm being a little conservative with my surface temperature, and I just did 100 degree surface temperature on that one, okay? Then what we do is we can configure the ceilings. My floor is concrete, so I went ahead and used the normal information they have in there. And then also my ceiling is polyurethane, and I went ahead and did 110 degrees because that's my max ambient temperature for about 4 months out of the year at this location, okay? So once we've done that, you're going to put your air change load information. You can configure your door. You do have some, I have one man door on this, so you can do some automatic calculations. You know, for the door usage, you can change it to heavy duty, above average, all that stuff. Once we do that, you can change the amount of people in the box. This is a small box, so we're pretty good on that. You can change your estimate for the equipment. I just have it set to average duty. You can change that to heavy duty if you need to. And here's what we get. We get the capacity required at 11,013 BTUs per hour. That's what's required to maintain negative 10 degrees at 110 degree ambient based off of 18 hours of runtime per day, okay? So when you hit save and close, it's going to take you to your breakdown sheet, and you can see that it's going to give you equipment information. Now, here's the equipment that I'm going to use. I'm going to use a 4 horsepower condensing unit. I'm going to use a 10,000 10,000 BTU evaporator, 10.5, something like that. And it's going to give you, based off of the equipment, it's actually going to give you a better runtime because of the balanced capacity on it, okay? So your evaporator TD is going to be calculated at 9.8 degrees. So there's lots of really good information inside this, okay? Now, if you want to do custom equipment, you can also select the options, do all that good stuff. We can go to our actual sheet right here. This is your printout that I get to save. And I love these because they have all kinds of information in here. And you save these things so that way if you ever have a problem with the box, you know how someone sized it too. Another thing to understand is the refrigerant makes a huge difference on the equipment. We are using R-448a refrigerant, and I will mention it later in the video, but with R-448a, because of the glide in the refrigerant, we actually will, compared to 404, we're actually going to have to upsize the condensed unit, right? Because we're going to get a little bit less capacity out of the condensed unit, but we're going to get more capacity out of the evaporator during certain times of the year. So with that being said, the equipment is actually going to be a little bit bigger than normal. The original condensing unit on this system was a 3 horse. I'm going with a 4 horse now, and you'll see as we go through the equipment installation. But I love all this information in here. Gives you even a breakdown because I'm using their components. It gives you a breakdown of the equipment, tells you the dimensions, the standard stuff that's going to come on it, the evaporator information, gives you an AWEF number, tells you what the line sizes are. Now we're going to go through the line sizing right now too, okay? So the next thing that we're going to do is we're going to go to SPORLAN's virtual engineer, okay? SPORLAN.com, go on there, find the virtual engineer, open it up, input your information, and you're going to come to this sheet right here. And based off of, so we do our load calculation first. Once we've done our load calculation, then we select our condensing unit, we select our evaporator, we find out what our balance system capacity is, and then we're going to start sizing our components for the equipment, okay? We're going to size the expansion valve, the liquid line filter dryer, the liquid line solenoid valve, the suction line, and the liquid line itself, okay? All of that is going to be sized in SPORLAN's virtual engineer. I've already done all the work. You guys can walk through the tutorials and everything, but we're going to use an E3S130 liquid line solenoid valve. And if you click on this, it'll give you information on what we went through to size it. We're going to use a 164S, that's a sweat liquid catch-all filter dryer. We're going to use a 3/8 inch liquid line. We're going to use a 7/8 inch suction line, okay? And that's pretty much all that we need. Now, once we've done that, we also need to select our expansion valve, okay? Now, to select our expansion valve, we have to look into something else. With the new AWEF compliant refrigeration equipment, you have to understand that there is new factors that we need to consider when we are sizing our expansion valve for the system. Because we are floating our head pressure down during the winter and during the summer, we have to make sure that our expansion valves are sized accordingly. So SPORLAN has a tech document, Bulletin 500-10-AWEF, that they have done the footwork, okay? They have called majority of the refrigeration manufacturers out there, figured out the typical pressure drop across the distributors, figured out the standard, liquid temperatures that they're designing the equipment with and everything, and they've made it pretty easy for us, okay? So you actually don't even have to go through the virtual engineer and answer all the questions to size the expansion valve. You can actually just use this really cool chart, okay? So we're going to scroll on down here into the chart. We're going to find the refrigerant that we're using, which is 448A, okay? Here we are at 448A. And what we're going to do is we're going to see at our our evaporator temperature of -20, right? Because my evaporator is going to maintain -10 degree box temperature. We have approximately a 10 degree evaporator TD, which means that the actual evaporator temperature is going to be about 10 degrees below that. So that would be a -20 degree evaporator. At -20, you look and you find the right expansion valve based off of the minimum and maximum capacity of said valve. So if we take a BQ valve, right, that's the balance port buildable valve, and we take a B cartridge, it says that we can deliver 9,000, as low as 9,000 BTUs and as high as 16.8 thousand BTUs of capacity. So that's the one that we're going to use, all right? If we go back to, let me go ahead and pull this up. If we go back to our rapid spec equipment right here, it says that my evaporator is going to, we'll go right here to our balanced system performance. Let's see, balanced system performance, balanced capacity is 11,940 BTUs, okay? With that being said, that is under the 16,000, but that is over the 9,000. So this valve with this cartridge, a B cartridge, is going to work perfect for us, okay? So that is what we're going to use inside of our valve. Now, with that being said, we need to understand, if we're buying new refrigeration equipment these days, it's more than likely going to be AWEF compliant. With that being said, you can't just necessarily swap out a condensing unit like we used to. Let's say you have a bad compressor and it's easier just to change the condensing unit. You need to investigate your expansion valve if you're using existing equipment, okay? Because with the new AWEF compliant equipment, majority of them are floating the head pressure a lot lower, and that head pressure control valve is very rarely ever going to bypass, right? Because the bypass pressures are as low as like 100 PSI. Now, granted, this is a 448A system, so it's going to run very similar to R22 for a lot of us. That's an easier way to remember it. But so it's already going to run, you know, lower than normal head pressure as compared to like 404. But that being said, if you just go get a new AWEF compliant condensing unit and slap it on an existing system in low ambience, we might be running into some big problems, okay, with that expansion valve not feeding correctly because the pressure drop is too low, or who knows, okay? So keep that in mind. But with that being said, we know what size equipment we want now. We know what components we want to install on our equipment. We know what line sizes we need, okay? Now, really important to understand too, just because this particular condensing unit that you guys are about to see has an 1.1 inch suction line on it, but that's not what's required for our delivered BTUs. We only need a 7/8. Actually, we only need a 3/4 inch line set, but I'm going to use a 7/8 because it's readily available and I don't really have a lot of 3/4 inch components on my truck every single day. So we're going to go with 7/8. But you don't just grab the line size. This goes for residential equipment too. If you have a 3/4 inch line set and a 3/8 inch connection on the outside of the condensing unit, that doesn't necessarily mean that's what's required for the system to operate properly. Depending on the line set length, the rise, the drop, all that different stuff is going to determine what your line sizes need to be. So you don't just necessarily match up what's on the equipment you're installing and assume that's what your line set needs to be. All right, you have to do the research, look at the total equivalent length, find out what size lines you need, what's your pressure drop going to be, and all that good stuff. Okay, so let's go ahead and get on to the installation, and we'll talk a little bit more in the closing words.
All right, we are prepping this evaporator right now for replacement. We're going to go ahead and I like to prep them myself because I make sure the right nozzle gets put in there. We're going to get it set up for 448A, expansion valve, all that good stuff. We're also prepping our condensed unit. That's monstrous. I can't believe how big it is. It's just a 4 horsepower unit. Blows my mind how tall this thing is, but what it is they're only using a single pass condenser. They're not doubling it up like they normally do, so that makes it have to be a lot taller. Anyways, so we're just getting this going. All right, got the BQ kit. Of course, I love using this. It gives you the ability to build these expansion valves on the fly. And yes, you don't have to necessarily have the kit, but it's nice to have everything all consolidated in one place. So we've got the valve, the cartridge, and the power head. And you got to make sure you use the valve tag right there that lets the next guy know what cartridge you have installed in that guy. And I also put the nozzle already up in here. This unit came with 2 nozzles. I always save the extra one. If you look down into here, I actually carry extra nozzles. So this was the extra one that came with this kit. And then I have other ones down in here. So I always save them so that way if you ever need them in the future. And then I also have plenty of these strainers too, in case you ever need to clean a valve strainer on the fly. All right, we're gonna go ahead and sweat in this expansion valve. I just realized I used that as a prop, but we need to go ahead and put some of that on this valve right here. We already got this portion down here done outside. So now we're gonna do this part up here. We've already got the nozzle inside. This is bent. We have room for our solenoid coil, and we've got the nitrogen moving through the system right now. Okay, so we're using a rather small tip. We're using a 0 tip. You don't need a lot of heat. Okay, so I always like to try to pre-bend this guy. Make it a little bit easier. I get a lot of questions about this rod. This is Solder Weld's 15% round rod. I got no affiliation with them, but I really do like the round rod. Because you can spin it around in your fingers. It works the same. I mean, it's no different than any other solder. But okay, I know a lot of people say I use too much solder, but I just like to be sure. It's my company. I don't care if I use, and I don't care if my employees use a little too much solder. It's better than not using enough. Okay, so our next goal is to get this stuff off as fast as possible. We're going to do an initial cool real quick. And I know they say you're not supposed to cool down a braze joint, but when you have sensitive components like an expansion valve, you kind of have to. And then once we get it somewhat cool, we're going to pull the heat blocking compound off. All right, you can turn it off. You can very clearly see where the heat stops. You notice how this brass right here doesn't get overheated. The heat stops right here. Heat stops here. Now, if you come up here, I probably should have put some heat blocking compound up here too, but it's okay. But you got to be careful because a lot of times this is a Russell equipment. They use soft solder up here, like the low temperature solders, and it will become a problem. And then trying to mix, if you don't have the exact solder that they use, trying to mix like 56% with it is just a nightmare. So just be very careful, but that heat blocking compound really does work well. Now, we're gonna leave this uncapped. We'll put a cap on it, but we're gonna leave this loose, and we'll go ahead and pressurize the system with nitrogen. It'll just be the solenoid holding it back, and then we got to get into wiring the temp control and everything. All right, we are prepped as much as we can for today. We're going to use an ETC Ronco NEMA 4X stat, so it's the 141,000, 208 volt, does not have built-in defrost or anything like that. It's a solid controller just being used for temperature, but if you want defrost, then you want to go to like a Ketotherm one. We have a mechanical defrost clock on the roof that'll handle all that. So we just have it sitting here just for shipping purposes because we're going to take this to the job. We have it all wired into here. Hopefully I did it right because I did have to change some stuff up to wire in the 2-speed fan relay. So we're set up there just to land. All we got to do is land N, 3, X, 4, and ground. We land those wires coming from the condensing unit, then everything else should be honky-dory. So then you come over here, we've got the TXV mounted, solenoid valve mounted. We have room to move it around if need be. Sensing bulb, we'll terminate that once we get it piped in. We're going to leave this cap on until we're ready to do the install. Put a cap on this guy, and that's it. We're wired in. We're just going to put this together. This guy right here, we got the disconnect switch mounted. We need to get some 40 amp fuses for this guy. We're going to go with a standard electromechanical defrost clock. That's what came factory installed, which will make it easy. And everything else is good. So we just need to land 3-phase power here in the disconnect switch on the top, and then run our our interconnecting wires down to the condensing unit. Down to the evaporator. So we're gonna start putting this guy back together, and we'll be back on install day. Okay, we're demoing the old equipment. We've already got power turned off, so we're just disconnecting everything. We're gonna make new bolt penetrations on the top of the walk-in and line set penetrations. So the only thing that's going to be reused is the drain line. So we're just disconnecting everything right now. The new condensing unit's going to be relocated a little bit. We turned it around, some 4x4s across to spread the load. These units are so big now, and the load calculation called for a 4-horse. The old unit was a 3-horse. But when you go to a 448A, you lose a little efficiency in the condensing unit, but you gain it in the evaporator. So the evaporator is rated as a 10,900 BTU evap, but with 448A you get closer to like 12,000 or something. So anyways, all's good. So we're just checking everything out, kind of getting everything prepped. We got the hole drilled for a new line set. They're gonna have to get roofers out to seal this up. We need new coil bolts. The coil's hung. We'll abandon all this old stuff a little bit at a time. All right, it has been a heck of a day, but we've got this guy ran, electrical's hooked up to it. We're still kind of working. We're gonna get a cover made for this line set right here to keep the tweakers, you know, a little bit at bay. Everything's wired in here. So yeah, we're just about pulling the vacuum right now. It's looking really good. So we've got a SPORLAN suction line filter, and then a SPORLAN catch-all dryer down there. I like the way that they secure them and support everything. It's really nice on these Russell condensing units. They did a good job with the head pressure control valve, installing that. Everything on these things looks nice, and I love the SPORLAN love on these things. These guys, it's really nice. So, all right, we're getting ready to charge this guy. We're still in decay, 546. I've been moving this around, so it's kind of moving, but we're good. It pulled down to about 200 microns. Before I open up the system, I vacuumed down my gauges. I took off my big hoses, just vacuumed down the gauges. Then we'll open them to the system. We're gonna front seat this valve, put as much gas into the receiver as we can, and then start from there. All right, we're going to flip this cylinder over. We're using Honeywell's R-448a. I've been using this for a long time. Walk-in coolers and freezers, at least a year and a half now. I mean, it's really just another flavor refrigerant, guys. It's not that big of a deal. Just make sure your valves are sized right, your orifices or your nozzles for the expansion valves are sized right. Condensing unit, you typically gain, I already said it earlier, you gain capacity in the evaporator, you lose a little capacity in the condenser, so you typically have to oversize a little bit. And if it's low temp, even medium temp, but low temp for sure, you need to have compressor cooling. The DTC valve cools off the compressor because you'll have some overheat issues with these blends, so you got to be careful about that. All right, my system is running. I'm currently charging it with refrigerant. We've still got a flashing sight glass, so all we're going to do is clear the sight glass, and then we'll worry about our winter charge after that. But I'm waiting for my evaporator fan motors to turn on because they're not even on yet. So all right, we are back to do the official startup on this guy today. It's cold as you know what in here. It's about 0 degrees at the moment. Looks like it just turned on. Everything's working. I will say, just preliminary inspection, that frost right there means that we didn't seal that penetration enough, and we'll have to double up on that, get some foam on that, and then but we're gonna check the evaporator superheat, just go through all operations, make sure defrost is working and everything. All right, we're all probed up. Superheat's a little bit higher than I want it to be, but it's also kind of weird because our sight glass is flashing right now. So we're gonna add a little more refrigerant, get that taken care of, check the liquid level again, make sure we're not low. It's probably just needed a little more gas. Now, I mentioned that we had frost coming down. I didn't seal this because I kind of wanted a roofer to come up here, because since we had to penetrate the rubber roof membrane, I really wanted the roofer to deal with this. But we're gonna have to do something because the condensation was really close to going down this penetration. So I gotta go ahead and seal it with silicone or something. I'm not gonna mastic it because I'll let him make that. But we're also gonna put some more spray foam down there. But before we start adjusting TXVs or anything, we're gonna add a little refrigerant, get that sight glass cleared up, check the liquid level again, and then go from there. Got my suction probe down at the evaporator, so I'm able to monitor the pressures there. And then right here, I just hooked up and I'm just pushing it into the suction side a little bit at a time. Watching that sight glass, it's just about to clear up. It literally took a couple ounces. So we're gonna double check the liquid level again too. I have to also look in to see when that head pressure valve, the head pressure control valve, actually what bypass pressure. Usually they float it way down on these things, but I want to double check. All right, so superheat's still a little bit high. I'm in the box right now. We're gonna go ahead and adjust this valve to bring, so we're gonna bring the stem down to drop the superheat. Okay, I made 8 quarter turns, which should equate to about 2 full turns. So we're gonna give it some time, let it drop down. We're ideally looking for about 6 to 8 degrees evaporator superheat when it's down to temperature. When we make superheat adjustments, we really need to give the system time to stabilize. So immediately it dropped down to 0 degrees superheat, and it's gonna kind of find its happy medium. That's why, you know, obviously we wanna get the superheat as low as possible to get the most efficiency out of the coil, but at the same time, you tend to, especially on these mechanical valves, they go about 6 to 8 degrees because they don't want to flood back to the compressor. See, there's potential that when the valve opens, it's going to flood, you know, and go back and forth. So we run a higher conservative number of 6 to 8 degrees. That's also why it's pretty important to have suction line accumulators to help protect the compressor. But those are a whole nother story. You know, the screens, if people aren't properly installing the system, brazing with nitrogen, that kind of stuff, the screens can get plugged up and then the accumulators fill up with oil. So that's a whole nother issue. But point I'm trying to make is you make an adjustment and you give it time. Okay, we're gonna watch it kind of throttle, see how it reacts, and just kind of go from there. All right, that seems to be where it's gonna leave, right about 8.2 degrees. It's kind of still modulating. We're going to close up the evaporator coil, or at least the expansion valve side, and then throw the unit into a defrost, check the liquid level in the receiver, mark it, all that good stuff now. All right, so we're looking good. I wanted to point out something. We were just talking about this right now. These newer units, they're trying to get as much energy efficiency out of them as possible. So if you notice, discharge gas comes out of the compressor right there, runs in right here on this guy, okay? Goes into the condenser, comes out of the condenser right here, okay? Goes through the head pressure control valve to the receiver, then comes out of the receiver, right here, comes out of the receiver, goes back into the condenser again, then comes out of the condenser, goes through the sight glass and the liquid line filter dryer. They're doing that for efficiency. They're verifying that we have 100% proper subcooling. On these newer units, you actually have measurable subcooling. Looks like my valve is throttling again. But look at, we have measurable subcooling of about 6 degrees. So that's normal, but you have to understand these new systems because they're doing that for energy efficiency now. All right, at this point, we're gonna go ahead and pump the system down and check the liquid level in the receiver and mark it for the next guy. All right, so we have our receiver right here, and we heated it up when it was pumped down, and you can clearly see the liquid level right here. That's where it starts. So we're gonna go ahead and mark that guy, and then that way we know from this point forward, that is the full amount of refrigerant we can put in this system. All right, system's back up and running. We came over here and we marked the liquid level, 31 pounds of 448A. I also wrote that in the nameplate right here. We're putting all of our notes in here. I put system startup right there, 3/4 receiver level. The next thing we're gonna do is just go double check all the electrical connections, make sure they're tight, make sure the crankcase heater is working. Just doing a full startup on this guy. Then we'll put it into defrost, make sure all the defrost heaters are working. All right, so we've got a tech downstairs, and I verified everything when we wrote it down. So I wrote down the current of the crankcase heater, but remember that current is gonna change depending on the voltage. So 204 volts, 0.25 amps. Evap heaters, there's 3 of them. Total current at 204 volts, 8.5 amps. Individual heaters are 2.9 amps each. So we're good there. Everything's looking really good up here. We're gonna go ahead and start taking all of our stuff off. And I did make a pressure control adjustment because the compressor was short cycling a little bit. But it's doing good now. So we're just about done here. We are back today to cover up this line set so that way we can be done with this. Now we're gonna cover it up with this really thin galvanized and we're gonna paint it brown. All right, we didn't do anything crazy. We just notched the metal. It's not sealed whatsoever. We even left gaps underneath so that way water can flow. This is just to kind of make it look prettier, so, you know, public and stuff like over there doesn't have to look at it. You got all those cars and whatever. And then we're gonna paint it brown. We are gonna cut this back about 2 inches and they're still gonna have a roofer. Now I put that roof jack right there. The roofer may put something different, who knows? But at least there's something, he can choose to use it or not. He'll probably need to replace that flashing too, but that's not my thing. So we're gonna take it off. I'm gonna do one more cut right here and then we're gonna paint it brown and put it back on and be done with this thing. And again, it doesn't need to be sealed or anything. It's just a beauty cover. Just Just in case you wanted to know, we offer professional paint services too over here. And we paint match. We guarantee our paint match. If it doesn't match, you can call someone else. All right, it's not perfect. Somewhat matches the paint color. This is actually not the paint color. The paint color is on the side of their building right there. So, somewhat matches that. Good enough. Again, this is just to keep the attention away from the shiny copper is really all that this is for. The next time I come back, I'm not gonna do it now because the paint's all tacky. We'll write on it with a big fat Sharpie, do not step or something. You know, I don't want someone to walk on it. And then the roofer still has his stuff. And then as far, I can't remember if I already said it in the video or not, but I sealed it underneath with spray foam and stuff, and then just silicone. But that way the roofer can be the one to make the permanent seal. You know, he'll do what he wants to do there. And, you know, he'll realize that this is loose. He can move that if he needs to. So, all right, that's it. The customer's been happy. Walk-in's been working great for a while now. So, yeah, we're gonna wrap this one up.
When we do these installs, it's really about what the customer can afford and what they expect, what they want to spend, right? I would love to take all this equipment and put it on their main roof, but it's already on top of the walk-in cooler. In order to get it on top of the main roof, we'd have to go through some pretty complex stuff. If you guys paid attention, the brick on the outside of the building would have to be penetrated. You know, we'd have to do beauty covers and different stuff like that. So the customer just wanted it put back on top of the freezer, okay? It's not ideal. It's not the perfect situation. We tried to take those 4x4s and lay them across to evenly spread the load so that way it wasn't just leaning on the panels of the walk-in. These newer condensed units, they're huge. They are giant, you know? That's something we have to remember, and I can't stress enough, like when I was talking about doing the load calculation, you guys need to understand what this AWEF compliant equipment is doing and how low they're floating the head pressure, because if you try to throw an existing condensing unit on an existing system, that TXV may or may not be the right size, right? Especially since they're dropping that head pressure so low in the wintertime. So keep that in mind, all right? As far as the installation goes, of course, there's always stuff I'd love to do better about my installs, okay? I am not an Instagram tech that does these perfect, pretty, perfect installs. I wish I was. I'm constantly looking at what these other technicians do. We all feed off of each other. And when I see people do these great installs, they give me ideas and tips, you know, and different things to do. And I hope that maybe there's like one or two things maybe that you guys get, you know, that maybe you want to improve upon. You see something in my video, maybe you duplicate it, or you think, hey, I don't want to do it the way Chris did it. I want to do it better, you know, and you work off of that. And that's a good thing, right? Because I am not perfect and I never will be perfect, okay? So in this situation, we were having a real struggle with the equipment. The customer kept icing up the equipment. Now, one thing I will tell you guys, I told you that when I did the load calculation on this equipment that, you know, it required a 4 horsepower condensed unit with a, what is it, like a 12,000 BTU evaporator, right, to satisfy the load with the ambient conditions in this area. With that being said, what was existing there was a 9,000 BTU evaporator coil with a 3 horsepower condensing unit. So the condensing unit was oversized for the evaporator, but the evaporator was marginally sized for the load at the ambient that they run that walk-in at. Now, it's been like that since like 2003, I think, or something like that. Okay, it's been that way for a long time, but that does play a role in the equipment icing up as much as it had been. Now, things to understand, you know, we went through the operations of the original equipment. We told the customer, hey, it's working, it's doing everything it can, but, you know, here's what we're finding. It's marginally sized. The customers keep opening and closing the doors. And with all that being said, you know, the customer wanted to go ahead and upgrade the equipment. When we did the upgrade, we sized it properly, right? So that way it can satisfy the requirements under the ambient conditions. And also, to be fair, not to get political or weird in this thing too, the temperatures outside are rising, okay? This equipment, when it was originally installed, the ambient temperature might have only been 95 degrees, okay? Maybe 100 degrees at the most, but the temperatures are going up. It's getting hotter outside. We have to size our equipment appropriately for those higher than normal ambient conditions, okay? Keep that in mind. So as far as the install goes, it was pretty straightforward. Of course, there's things I could have done to make it better. In hindsight, when I'm editing the video, I didn't think about this in the time, but in hindsight, had I just extended that line set over and penetrated further inside the box, I probably wouldn't have to do such an extensive cover on the roof, right? And we wouldn't have had that penetration, because it's kind of awkward getting to that. And I did flip the equipment so that the condenser faced the wall. That way it gave us, you know, a little bit more room to work up there. But at the same time, it puts the line set right in the area where a technician would be kneeling down. And that's why I went back and wrote, or wanted to go back and write on it. I haven't been back yet, but wrote on that cover that I made, do not stand or whatever, right? Because I don't want someone to lean on that and it'll just shatter, crush, because I think that's like 20 gauge galvanized or something, so it's not very sturdy. But, you know, in hindsight, I should have extended the line set more inside the box over and then penetrated up, because then there would have been less on top of the roof, you know. But you live and you learn. They also still need to get an electrician out, because I wanted the electrical service upgraded. The wire size is marginally sized. I think they had 12 gauge wire going to that. It's got a 40 amp max circuit ampacity, but the breaker size was too small. So we increased the size of the breaker while we were there, but because of the complexity, we want an electrician to get out and increase the wire size to 10 gauge going from the breaker all the way to it. Now, to be fair too, they say 40 amp breaker is the max size for that system, but it's only running like 21 amps of current. Okay, so with the 12 gauge wire, it's okay for now, but I still want them to increase the size just for safety reasons, just to be cautious. Okay, you know, when it comes to working on this equipment, I do not know everything. When it comes to doing load calculations and different things like that, this is just what works for me. I encourage you guys all to check out and do your reading, research, load calculations, research line sizing. There's so much misinformation out there. People giving wrong information or just assuming because the system has a 1 1/8, because this particular condensing unit had an 1 1/8 suction line coming off of it, but it didn't require that. And the evaporator had a 7/8 inch suction line coming off of it. Because of the capacity, it actually only required a 3/4 inch suction line. But like I said, I went with the 7/8 because it's more readily available, and I keep those fittings and everything on my truck. I have very minimal 3/4 inch truck stock for refrigeration line sizing. Refrigerant lines are sized according to pressure drop, oil return, and refrigerant velocity. Keep that in mind. Going to 448A is a very similar gas to R22. From 404, you are going to drop in line size, okay? You can put bigger lines on there, but it's going to change the pressure drop. It's going to change the oil return and different stuff like that. So you always want to do your research. Definitely look into that rapid spec program for doing load calculations. I really do like that, especially when I do the Russell equipment. I really like using it. But more importantly, check out the SPORLAN Virtual Engineer. It really does help you to understand the things you need to consider when you're sizing expansion valves, liquid line solenoid valves, liquid line dryers, any other SPORLAN component that they sell. They have sizing information on that Virtual Engineer website. Okay, so definitely check that out. I really, really do appreciate your guys' feedback. I appreciate your support. So please leave me some comments. Let me know what you think. Feel free to send me an email to hvacrvideos@gmail.com if you have any questions or things you want to talk about. I will definitely be talking about this video on my next live stream that I am able to make it to. So stay tuned for that. My live streams are typically Monday evenings about 5 p.m. Pacific on YouTube if I can get off work in time. Okay, so it really depends. Keep in mind, if you guys haven't already, definitely check out my website, hvacrvideos.com. We have some merchandise available. It's a way to help support the channel. But the easiest way to support the channel is watch the videos from beginning to end without skipping through anything. That's the simplest way, okay? Then you have the website. You can also support the channel via Patreon. You can support the channel via YouTube channel memberships, via PayPal. If you have any interest in purchasing tools, you can go to truetechtools.com. You can use my offer code Big Picture. If you use that offer code, that's one word. As of today, it is September 11th of 2021. You get an 8% discount on your order if you use my offer code Big Picture. And if you know what you're going to purchase from True Tech Tools ahead of time, shoot me an email. I can generate an affiliate link. I'll get a little bit of an extra commission when I do that, but you still get to use my offer code Big Picture to save 8% on your order. Okay. Thank you guys. You are amazing. I really appreciate you. Hopefully this video is cool and you guys like it. And remember, I've been saying this a lot lately. let's be kind to one another. We definitely need more kindness in this world. We have a lot of craziness going on. There's so much animosity. There's so much hate, so much anger. And a lot of the stuff we genuinely don't have very much control over, okay? So just keep in mind, do a good deed for someone else. Be kind to one another. It's simple as holding a door open for someone. Help someone out. Answer a phone call. You know, just do anything. Help your neighbors out. Be kind to one another and just spread the kindness. We definitely need more of that. I really appreciate you, and we will catch you all on the next one, okay?